Hello all, this is Mr. G, and this is our warm-up for today's lesson. So pause the video right here, give this problem a shot, come back when you think you have an answer. We're going over in 3, 2, 1, let's go. It says graph g of x equals negative 1/2 times the absolute value of 6x plus 9. Now immediately, as soon as we see this, I'm going to need a little bit more space. Let's slide this down. As soon as you see this absolute value right there, the absolute value bars, a couple things should jump to your mind. One, you should think, okay, I know that we're going to have a v. It might be a right side V or an upside down V. We don't know that, but it's definitely going to be a V as soon as we see those absolute value bars. The next thing you should think is, oh, I need vertex form. I need this in the form A times the absolute value of x minus h plus k. So to graph this 6 is going to be a problem. That 6 is going to be a problem. We need that to be a 1. So let me rewrite this so we can actually get started working. So it's g of x equals negative 1/2 times the absolute value of 6x plus 9, and there we go. So basically we need to use a GCF with that binomial inside the absolute value. We need to divide both of these numbers by a 6. Now I know 9 divided by 6 isn't going to be a nice number, but it doesn't matter. This must be a 1. The only way to make that a 1 is to divide by 6, because anything divided by itself is 1. This graph is not behaving. There we go. Finally got it out of the way. G of x equals, let's see, negative 1/2 just comes down, times the absolute value. Now remember, GCF is the opposite of distributing. Instead of multiplying into parentheses, we divide out and create parentheses. So the GCF goes first. That's where we're dividing out of the 6x plus 9. And the 6x plus 9 then turns into, let's see, 6 divided by 6 is x, plus 9 divided by 6. We could leave that as a fraction, 3/2, but we're going to have to graph this at some point, and I think decimals are a little bit easier to graph. So I'm going to leave that as 1.5. Now we've got to use our absolute value property. So I'm going to show all my work here so I don't lose anyone. So it becomes negative 1/2 times the absolute value of 6 times the absolute value of x plus 1.5. Remember, we're only allowed to do that because we have multiplication between two things inside the absolute value. Then let's see, that becomes g of x equals negative 1/2 times, first we got to take the absolute value of 6. What am I doing? So it's negative 1/2 times the absolute value of 6 is 6, and then we copy the rest of it. If you're good enough to skip some of these steps, that's a good thing, ladies and gentlemen. I'm just showing all of my work. Then finally, in vertex form, this is going to be negative 1/2 times 6 is negative 3 times the absolute value of x plus 1.5. Now we're finally ready to find our h and k and our a values. So h and k are the vertex. The h value, it looks like it's a positive 1.5, but remember, when we take it out of the vertex form and write it as a ordered pair, the h value, we have to change the sign of the h value. How do I want to say that? We change the sign of the number that's in there to get the h value. That's a better way to say it. So positive 1.5 means that we change the sign, so the h value is negative 1.5. And the k value, this throws off some students because k is supposed to be right there and there's nothing. Well, let's think about it. Okay, k is whatever we add or subtract out there. If there's nothing out there, we're just adding or subtracting nothing. So k is 0. So our vertex is negative 1.50. So I'm going to graph that. Let's see. So negative 1.50 will be right there. Yeah, it's not perfect, but it's right there in the middle, in between negative 1 and negative 2. Now our a value, our slope is negative 3. Now before we graph this, a lot of students were giving me sort of questions about this today. When I say, okay, a is negative 3, and they're like, all right, so what direction do we go? Well, it's still sort of like slope, negative 3/1, but we need to know what's so special about this point. That point is the vertex. That is going to be the point of the v, right? So our v is either going to go like this, or it's going to go something like that, right? Now we see it's a negative a value, so if we remember this from algebra 1, we know it's going to be an upside down v. But even if you don't remember that, just follow your slope, or slope in quotes. So it's negative 3/1, so from here I go down negative 1, 2, 3, and then a full step. So we're going to land halfway in between 0 and 1 there on the x. So that's right here. And then I just keep on going. 1, 2, 3, 1. Get a little bit more space. 1, 2, 3, and 1, still in the middle. And there we go. So that's one side of the V. Remember, this is going to look like a V. That means we don't want to go up 3 and left one. That's going to give us a line. We want this point right here to be the vertex, to be the point of the V, which means we have to go down 1, 2, 3, and left one. That's going to create sort of a mirror image of a V, a mirror image of those points. So that's going to be one point right here, down 1, 2, 3, there, 1, 2, 3, and then we can create our V. Hand is sort of in the way, but there we go. Excellent. My lines aren't perfectly straight, but you get the idea. So that's our graph, and that's all we had to do for the warm-up, right? Just graph it. So we are done. That's our answer. All right, let's jump into our objective. Today we're doing chapter 3, section 3, and after today we should be able to graph systems of inequalities, including absolute values. Graph systems of inequalities, including absolute values. So today we're sort of going to combine the last two sections we did. The last two lessons we did. 2 lessons ago, we talked about graphing systems of linear inequalities. Yesterday, we talked about absolute values and graphing them. Now we're going to put them together. So at this point, I think you already have 95% of the skills you need to move on and complete today's assignment. But there's one thing I want to review, and it's how we graph absolute value inequalities. So, all right, a lot of it stays the same. So like a solid line or dotted line, if it's an or equal to, it's a solid line. If there's no or equal to, it's a dotted line. That's just like we did with the linear. But the shading can sometimes confuse students. Sometimes students get a little mixed up. So that's what we're going to talk about now. How do we shade when we're graphing absolute value inequalities? When we're shading an absolute value inequality, we want to follow the exact same rules we did with a linear inequality. In a linear inequality, we thought, okay, do we shade above or below? That's what we do here. Right? A lot of students get themselves mixed up when they think, oh, it's a V. Now I have to think inside the V or outside the V, but you don't want to do that. Still just think above or below. So let's take a look here. We've got Y is greater than. So if Y is greater than, Y is bigger, so we would shade above, and that's exactly what we have here in this absolute value inequality. It's shaded above the V. So the graph here is the same. It's the same dotted line, dotted V, but now it's Y is less than. If Y is less than, we think, okay, Y is smaller, so we shade below, and that's exactly what we have here. It's shaded below the V. So now we've got an upside down V. So we flip the V, but Y is still less than. Okay, so Y is less than. We think that means Y is smaller. If Y is smaller, we shade below, and that's exactly what we see here, shaded below the V. Now we've got an upside down V again, but here, Y is greater than. If Y is greater than, we think, okay, Y is bigger, so we shade above. We shade above, right? So don't think inside the V or outside the V. That's only going to get you confused. Like, for example, here we have a Y is greater than, and it's outside the V. But the first one we saw was Y is greater than, and we shaded inside the V. All right, so inside and outside, that's just going to get you confused. Think above if Y is bigger, and below if Y is smaller. Today's lesson is going to be a little bit different, ladies and gentlemen. I've got 4 examples for you to try, but I want you to give them a try first. I think you should have all the skills at this point to try these problems. You might make a little mistake here or there, but I think you can do it. So I'm going to show you these 4 problems. Feel free to pause the video when I get to each one so you can write it down. Then give them a shot and come back and we'll go over the answers together. So here's number 1, number 2, number 3, and number 4. So give these problems a shot. Come back when you think you have your answers. We're going over in 3, 2, 1. Let's go. Now, in case anyone just wants to see the answers, I'm just going to show you the answers real quick. So here's number 1. That's what I got for number 1. Number 2. Number 3. And number 4. Now, I know my face was in the way for a few of those, but hopefully that gives you an idea of whether you did them correctly or not and which ones you want to go over in case you don't want to watch me do all 4 problems. All right, let's jump back and go over number 1. So I see 2y is less than x plus 10. So let's color code this so it's a little bit easier to follow. Now, right away, I know this will not be a v. There's no absolute value, so that blue one is not going to be a v. So let me copy down here. This is going to end up being a line, so that means we don't want vertex form. There's going to be no vertex. We want slope-intercept form. Y equals mx plus b. So let's get y by itself. So that becomes y is less than, obviously we divide by 2 there to get y by itself. We know there's a 1 in front of that x, so it's 1/2 x plus 5. Now we just graph. So I go to my y-intercept of 5, which is right there. Then the slope is 1/2, so I go up 1, right 2, up 1/2, up 1, right 2, up 1, right 2, keep on going, keep on going. All right. Now we do the same thing going in the opposite direction, or not the same thing, we reverse it, because this needs to be a line. So I go down 1, left 2, down 1, left 2, down 1, left 2 as many times as I can. And remember, we know it's a line because there's no absolute values. There's no absolute value, so it's not going to make a V. All right, now let's worry about the inequality stuff. It's less than, so it's going to be a dotted line. Well, I guess we could just leave those dots there, but I'm going to put a dotted line there just to emphasize it. And shading, let's do this carefully. Y is less than, so we're going to shade below this line. So I'm just going to do a little shading right now so we can see where the shading overlaps. Okay, blue's done. Now let's take a look at the green. So as soon as I see those absolute values, I know I've got to treat this one differently. This is going to be a V, so I need this in vertex form. Let me copy this down here, need a little bit more space. So that's going to be y is greater than or equal to the absolute value of negative 2x plus 1. All right, so let's take a look. This is not in vertex form because we need a 1 in front of the x. I see a negative 2, which means we need to use our GCF trick to sort of manipulate this to get a 1 in front of that x. So I'm going to divide everything in there, everything in that absolute value by negative 2. So let's go through this. This becomes the absolute value of, we put our GCF first, we're dividing it out in front and creating the parentheses. Let's see, negative 2 divided by negative 2 is just x. Well, the x comes down, I should say. And then 1 divided by negative 2 is negative 1/2. I guess I could put a negative 0.5 there, but we'll deal with that in a second. All right, not quite in vertex form, but we're getting closer. If you can skip some of these steps, that's a good thing. I'm just showing all my work. Since we've got multiplication there, we can split this up into two absolute values. Absolute value of negative 2 times the absolute value of x. And here I am going to change the fraction into a decimal because that'll make it a little bit easier to graph it. And last but not least, we say, okay, y is greater than or equal to the absolute value of negative 2 is positive 2 times everything else just comes down. Now we're in vertex form. You don't need to write out the vertex, but I'm going to. This is where we get our h value from, and we have to change the sign so it becomes 0.5. And just like in the warm-up, there's no k value there, so I just put 0. I just put 0. And we know the a value is a 2, so I'm going to put 2 over 1. So 0.5 is 0. That's going to be right here. And let's see, what was the slope? It's 2 over 1. Now remember, this is going to be a v. This point right there is a vertex. That's the point of the v. So we're going to go up 2 over 1. Just double checking my slope again. Slope in quotes. So up 1, 2, and over 1. Put this in the middle right there. And then we keep on going. 1, 2, 1, 1, 2, 1, 1, 2, 1, all as many times as we can. Now we don't go down and left because we want to get a v. We know it's a v because it's an absolute value. You need to make that connection, ladies and gentlemen. So from our vertex, we go up 2, and then left 1 to create this mirror image of the other side of the v. So I put a point right there, then up 2 over 1, up 2 left 1, I should be saying, 2, 1, and there we go. And now let's go back to our green. It's y is greater than or equal to. Since it's or equal to, it's going to be a solid line. And since y is greater than, we shade above this v. So it's above the v. So now we just have to find where the shading's overlapping. The shading will overlap right there in that triangle. That's where our solution set is. All right, that's number 1 out of the way. Let's take a look at number 2. All right, so let's do that one in blue, this one in green. Right away we see that the blue is, there's no absolute value, which means it's a line. And that's actually already in slope-intercept form. I need a little bit more space to get my face out of the way. So the y-intercept is -8, so I go to -8 on my graph. What was the slope? It's a -1 for an m value, so I go down 1, right 1. It's like a -1 over a positive 1. And then we reverse it in the opposite direction because this needs to be a line. There was no absolute value in the blue one, so it's a line. So I go up 1, left 1, up 1, left 1, keep going. Basically, ladies and gentlemen, once you start graphing, or how do I want to say this? Before you start graphing, you need to have an idea of what it's going to look like. You need to know whether it's going to be a line or a V. You can't be trying to figure that out as you're graphing. You need to know that as soon as you look at your inequality or equation. Y is greater than or equal to, so it's a solid line. And greater than, correct. Y is bigger, so we shade above. So we're shading above this blue line. Okay. Wasn't too bad. Now let's do the green. Oh, the green isn't too bad either. We see that there's already, well, let me take a step back. First thing we got to see, it's absolute value. That means it's going to make a V. It's going to make a V. So we have to get it in vertex form, or we have to look for vertex form rather, which we already have because there's a 1 in front of the x. The x is not 1, there's a 1 in front of the x. So we just go straight to our vertex. The h value is going to be a positive 1, the k value is a positive 2, and the a value equals 1. This threw off a lot of students when I taught this lesson today. They thought there was a 0 out there or something. If there's, how do I want to say this? Just like if we have an x, if there's nothing in front of that x, we know that there's an invisible 1 in front of it. But we don't write that because 1 times x, well, it's just x. Like putting 1 times it doesn't change anything at all. Similarly, if we have the absolute value of x minus 1, what number is in front of that absolute value? We can put an invisible, I didn't want to get rid of all of that, we can put an invisible 1 in front. Because a 1 times whatever that absolute value is, multiplying by 1 isn't going to change it. So we're not going to write that every time. We just have to know it's there. So the a value is 1, and we could put 1 over 1. All right, so I'm going to graph my vertex, 1 and 2. Again, that's the vertex. That's the point of the V. So this is sort of going to be where our mirror is when we're looking for the reflection, the mirror image of the V. Now I'm going to go up 1 over 1 for our a value, up 1 over 1 as many times as I can. And then we go back, and we don't reverse it to get a line going this way. It's going to be a V. It's got to bounce up to the other side. So I go up 1, left 1. You have to know what kind of shape your graph is going to be before you start graphing it. Got to know. You don't have to know exactly where things are going to be overlapping or like exactly where all the points are going to be or the intercepts or anything like that. But you got to know, is it a line? Is it a V? Okay, where was I? Okay, it's not or equal to, it's just greater than, so this is going to be a dotted V. And then shading, y is greater than, looking right there, y is greater than, so I shade above. So we shade above the V. Now we have to ask ourselves, where is the shading going to overlap? Well, if we're shading all above that blue line, the only overlap I'm going to see is what's inside the V. So really, everything above the V, I should say. I just made that same mistake. I shouldn't have said inside the V, even though it is. Everything above the V, that's a better way to think about it. Everything above the V is going to be the solution set, not just for the green inequality, but for the blue as well. So that's our solution set. Jumping to number 3. All right, graph the system of inequalities, same directions. I don't know why I even read that. It's been the same directions the whole lesson. We've got 1 blue, 1 green, we're color coding. As soon as you see that blue inequality, you got to think that's a V. You see those 2 absolute value bars, that's got to screen out to you, that's got to jump off the screen to you, and you got to think, oh yeah, I know what that means. That's going to be a V. And this is already in vertex form. It's already in vertex form because we see a 1 in front of the x. So let's just find the h and k. The h value would be a positive 6. The k value is a positive 3. Let's graph that vertex. So that's 6 and 3 right here. Now let's find our a value. The a value is a negative 1. You can think of it like a negative 1 over 1 if you want, if that helps you. And now we just graph it. So from our vertex, I go down 1, right 1, down 1, right 1 as many times as we can. And we know it's got to be a V, so it's not going to be a line going that way. It's got to bounce down. This is going to be an upside down V. You have to know that. Got to know that, ladies and gentlemen. I know I'm saying that a lot, but I really want to drive that point home. So we go down 1 and left 1 to create our V, the mirror image of the other side of the V, as many times as we can. Need a little bit more space here. And there we go. Okay. Dotted or solid line, let's see, looking right there, it says y is less than, it's not or equal to, so it's a dotted V. And since y is less than, it was less than, correct? That means y is smaller. Yep, again, looking right there, since y is smaller, we shade below. So I'm going to just put in some of the shading right now. So that's where the blue shading is going to be. Now let's take a look at the green, which is, oh, this one's not too bad. It's just y is greater than 5. Since there's only one variable, a y, on the y-axis, we go to 5. And then we cut across that, so it's going to be a horizontal line, a horizontal line that is dotted, since it's not or equal to. For the shading, it says y is greater than. Since y is bigger, we shade above. And here we've got a bit of a problem. When you looked at the answer I had for number 3, I wouldn't have blamed some of you if you thought, Mr. G didn't even finish that one. I mean, there's no shading at all. But look at the green and blue shading. Here's my question to you. Where are they overlapping? They're not overlapping at all. So that means there is no solution to this system of inequalities, because there's no ordered pair we can pick that will work for the blue and the green, because the blue and green shading will never overlap. That's why when I gave you my answer, I just left it at, well, there's no shading. There's no solution set to even shade in. All right, just one more to go. Let's take a look at number 4. It's color-coded, blue and green. As soon as you see this, you got to think, oh, I see 1, 2 absolute values, so we're going to have 2 V's for this one. So the blue, we got a little work to do here. I'm looking for vertex form. That means the x not has to be by itself, but we want a 1 in front of it, and we see a -2. Oh, actually, we don't even need to use a GCF here, because there's no binomial in there. It's just a -2 times x. But in there, when I said no binomial in there, I mean no binomial inside the absolute values. It's just a -2 times x. Well, if we're multiplying two things in an absolute value, we can split them up, as long as they're real numbers. So absolute value of 2, excuse me, let me just rewrite that. That was tough to see. The absolute value of -2 times the absolute value of x minus 5. Let me just move this graph down because it's already in the way. There we go. Where were we? Okay, so I can rewrite this now as y is less than or equal to the absolute value of -2 is +2. So 2 times the absolute value of x minus 5. Now we just got to find our vertex. So here we see a vertex. There's nothing being added or subtracted in there with the x. So that just means the h value is 0. And the k value is a -5. We leave that sign the same. And a is 2/1, our sort of slope. Right. Now it's time to graph this. So 0, -5 is right there. And the a value is 2/1. So I go up 2, right 1, as many times as we can. And hopefully you know this, ladies and gentlemen. Since this is going to be a V, we need to turn on the vertex. So that means I go up to left 1 to create a mirror image. Now, one common mistake students think is, they think, so a V always turns on an axis. The point of the V is always on the axis. And no, I mean, it happens to be this time. But look at that. Look at this one. This V turned nowhere near an axis. Okay, so don't think it has to start turning at the axis. It starts turning at the vertex. That's why the vertex is the most important point of an absolute value function. Solid or dotted? I forget. It's less than or equal to, so it's solid. So there's 1 and the second part of our solid V. And we shade, it's less than or equal to, so we're going to shade below. So the blue shading is going to be everything below that V. Okay, let's take a look at the green. So let's do our work right next to it. The green is y is greater than or equal to 1/3. 1/3, let's just rewrite that. 1/3 absolute value of x minus 1. That's already in vertex form. Yeah. Oh, there's a 1 in front of the x. We're good to go. So h is +1. Again, there's no k value, so it's just 0. And our a value, our quote-unquote slope, is 1/3. Let's graph it. So 1, 0 is going to be right here. 1, 0, and I already forget the a value. 1/3. So I go up 1, 1, 2, 3, 1, 1, 2, 3, 1, and 3. And we flip it in the opposite direction to create a mirror image for our points for a V. So up 1, left 3, 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, as many times as we can. There we go. Let's check our sign. It is or equal to, so it's going to be a solid V for the green. So 2 solid V's here. And shading. It's y is greater than, again, looking right there. So y is greater than means y is bigger. So we shade above. Now we say where is the shading overlapping? Where do we see both blue and green? And we actually see it in two sections. I see blue and green shading right here. So that's a solution set. But I also see blue and green shading right there. So we actually have, I was going to say there's two solution sets, but that's not really the best way to say it. Our solution set, when we graph it, looks like two different shapes. Maybe that's the better way to say it. It's not all combined in one area. There's two areas to the solution set. That's probably the best way to say it. All right. Hopefully that made sense. If you didn't get any of these answers when you try them on your own, hopefully the explanation I just gave you helped. But if not, by all means, reach out to me. I'll be more than happy to help. Enjoy the rest of your day.